Hello, this is Mrs. Ringrose, and we are on to trigonometry, which actually stands for the study of triangles, in case you didn't know it. And we are going to approach it using the unit circle. There's different ways to approach it. And before we do anything in class, I wanted you to first be introduced to the unit circle, and that's what the goal of this video is. Okay, so this is an introduction to what's known as the unit circle. And again, we're doing this because I'm going to refer to it a lot as we talk about trigonometry. So the reason why we have these functions is because in real life there's a lot of phenomena that has what's called periodic, such as the cycles of the sun, the moon, the tides, even our natural moods and everything like that is periodic throughout the year, throughout the month. And so we have these functions that go on forever, but they don't just go up forever, such as, a line or a cubic function, and they don't just go down forever, such as a quadratic that opens down. It actually just keeps moving up and down, up and down, up and down forever. It's a motion that increases and decreases. A circle is actually defined as the set of all points equidistant from a center. So if you think about a circle, you might have a center, and then you have all these points around the center that are all the same distance. And we get that all those points are the same distance from the center because we have a formula that can tell us the distance. So if this is x comma y, my center, then I can use the distance formula to find the distance between that point on my circle, that point on my circle, that point on my circle, and they all should be the same distance. So, and the distance is actually the radius. So if we take this distance formula and I change d to radius, then that's where we get an equation to a circle. Because the next thing you might notice, the difference between what I wrote down there for the radius, because it's our distance, is if we square both sides, then you get what's down below is the equation of a circle, right here. And it's actually equal to x minus the center squared plus y minus where the center is squared, and it equals the radius squared, because we have to square both sides. So what's really useful to us is we have this thing called a unit circle. And so imagine that these are your axes, and the unit stands for 1. So you have a radius of 1, and our circle just goes through all these points, and we put the center of our circle at the origin to make all the math easy. So I'm sorry that that's a terrible circle, but you get the idea. Therefore, the equation for a unit circle, starts off, you don't have to write this yet, but starts off as this plus this, because we center on the origin, equals our radius squared. And what you should know, if we simplify a little bit, is x squared plus y squared equals 1. So this is the part that you really need to know. That is our equation for the unit circle. So one of the advantages to using Desmos, I know I like to switch back and forth. I like one thing for some things and one thing for other things, is that you can input other things where y is inside my equation. Actually, I can input equations. On a TI graphing calculator, I would have to solve for y, and I would have the square root of 1 minus x. Sorry. And then I would have to do the square root of x minus 1. And then I would have to solve for x, and it just gets really complicated to try to get a circle. But in Desmos, all I have to do is type in my equation, and there we go. So a couple of the things that is nice to know how to do is to show that a point is actually on the unit circle, and then maybe to solve the other way and find the y coordinate on, or maybe perhaps even an x coordinate using that equation. So the first question is, point is going to be on my unit circle, and it must satisfy that equation, right? So here's my unit circle, and here's any xy, and we need to find out. Okay? And we want to prove that that's on my circle. So all I'm going to do for this is plug in radical 3 over 6 squared, and for my x value right there, plus radical 6 over 3 squared, and find out if that in fact equals 1. The first one, I can square both the numerator and the, oh, well, Mrs. Ringrose, there we go. So on the first one, I can square both the numerator and the denominator. That's how you square fractions. So now I have 3 over 9. And my second fraction, again, I'm going to square the numerator and the denominator. So I have 6 over 9. And the question is, if I add 3 ninths to 6 ninths, do I get a whole? And the answer is yes, because 9 over 9 equals 1. So I can say that this point is absolutely on my unit circle because I plugged it back into the equation and it was true. The next question is something that requires a little bit more thought because I have a squared. So I might have two solutions, but everything inside this problem gives us the information we need to find one answer. So we're told that I have a point that is on my unit circle, and I need to find the y that satisfies that. So I'm going to start by plugging this in to my equation and solving for y. So now I have 3 over 4. And I'm going to subtract 3/4 from both sides. So I have y squared equals 1/4, right? And then I want to go ahead and take the square root of both sides. So y equals the square root of 1 over the square root of 4, which is 1 over 2. And normally because I solved for a quadratic, you know, you would tell me that if there's a positive answer and there's a negative answer. But wait, there's more. So if you look back at the information in the problem, it tells you that this lives in quadrant 4. So if you think about our quadrants in our circle, got 1, 2, 3, 4. This point has to be the point radical 3 over 2, comma 1/2. And it actually has to be negative 1/2 because it lives in quadrant 4. If we're talking about the other solution, it would be up here in quadrant 1. So there's actually only one answer to this. So my y coordinate has to be negative 1/2. That is a point on this unit circle. And that's all I really wanted to show you today. So just have a general understanding of the unit circle and how it has that equation and how we can solve for points that are on the circle, which is going to happen a lot, and understand where it is positioned on the coordinate plane. Ta-da! Our beautiful unit circle. And we will, when we meet again, we are going to use the unit circle to find locations on the circle using angles and talk about something called radians. So I hope you look forward to that. Have a great day.